Okay, this problem is a little bit trickier. We're going to find the area of the region bounded above by the line y equal to x and below by x squared plus y squared minus 2y equal to 0. So I know that what I want to do is set up a double integral with nothing inside so that I find an area. And then I'm going to be bounded above by the line y equals x, so that one's not too bad to write. But then below by this. And what I have to note is that x squared plus y squared minus 2y equal to 0 is a completing the squares problem. So y minus 1 squared is y squared minus 2y plus 1. So it addresses my y squared minus 2y, but there's an extra 1. So I better add it on the other side to keep everything equal. And this is an equation for a circle with radius 1, where the x center is unchanged. Sorry, the x coordinate of the center is unchanged, but the y coordinate of the center has been moved up 1. So its center is right here at 1, and then it's just a circle with radius 1. If I could draw circles, that's what it would be. But I can't draw circles. That part of the curve doesn't matter, so it's fine. And I'm thinking about this region right here, which is kind of weird looking. So it's going to be fun to set up. I'm going to go ahead and write my dA as r dr d theta so I don't forget about that extra r. And then I have to think about how to represent this. And I didn't draw it very well, but the circle really does come down low enough that we're touching the origin at some point. So my radius r definitely has lower bound 0 because the origin is part of my region. So the furthest I ever am from the origin is on the origin, distance 0. But the distance I go out is kind of weird here. So the furthest distance I can go is that one. But there's kind of like all these closer distances in this really small little wedge that I've drawn. And I have to figure out how to represent that. So when in doubt, just go back to the equations you're given and kind of see what happens. So the thing that's giving me trouble is this lower part of this circle. Circle was given by that equation. So I'm going to go ahead and start from using that equation and see what happens. So that was given by x squared plus y squared minus 2y equals 0. Let's see. So that's x squared plus y squared equals 2y. The reason I'm doing that is because x squared plus y squared I know is r squared. And 2y, I could go back to my list of substitutions, is r sine theta. 2 times that is 2y. And so now, this is an equation, r is equal to 2 sine theta. So when I'm on the circle, my radius r, the distance I am from the origin, is given by 2 sine theta. So kind of when I'm making a very small sweep theta, I'm basically at the origin, but then for my bigger sweeps, it kind of starts to spin out more. So my upper bound is 2 sine theta. And then all I have to do is fill in my bounds theta. So I know that the furthest I go is for sure that pi over 4 we've seen several times now. And then the closest I go, again, this is suffering because I'm so bad at drawing pictures, but I really do touch the origin here. So my theta really is on the x-axis at some point. So the closest I ever am to the x-axis is 0. And so that's my integral. I'm going to write it out again. a little bit more neatly before we evaluate it. Oops, forgot to close out my bracket. Okay, so I do my innermost integral first. Integrating r with respect to r is just 1/2 r squared. And I want to evaluate that from 0 to 2 sine theta. So that's going to give me 0 to pi over 4. 1/2 times 4 sine squared theta minus 0 squared. So I'm going to pull out this 1/2 times 4. That's just 2 out front. And I'm integrating from 0 to pi over 4 sine squared theta d theta. And you would have to do a trig substitution here. Sine squared being 1 minus cosine 2 theta or something like that. I don't know. But this becomes one half theta minus sine 2 theta over 2, evaluated from 0 to pi over 4. That's a trig identity. I'm not going to take the time to actually do it, which simplifies to theta minus sine 2 theta over 2. I don't have room here. Okay. So the 2.5 cancel out. The theta part, pi over 4 minus 0, just gives me pi over 4. Minus sine pi over 2 gives me minus 1/2 times 1/2, so minus 1/4. And then minus sine 0 gives me 0, so that's the answer.